What's up guys, I wanted to show you my first super resolution program. It's called Argos engine, and it is a super resolution software for satellite imagery and drone imagery, RGB, as you know, color imagery in satellites, near infrared and shortwave infrared, and thermal imagery in drones. The first thing I want to show you is the device we can select. In this case, we have an RTX 5070 as a GPU. We can select any device we have installed in our computer. It works with any GTX RTX series, but I recommend 40 series, 50 series, and 60 series. Of course, we can use our CPU, but it's going to take much more time. Let me show you the models we can use right now in Argos engine. The first one is an RGB satellite super resolution. It's a HUD model. Our input is an RGB image, or plural images. We can select up to 10,000 images at a time to reconstruct. But we have this model works with a tile 64 times 64. It's the size the model was trained to reconstruct. 64 times 64 times 4. In this case, we have a tile 64, and times 4 is going to be 256. We have the near infrared and shortwave infrared super resolution model. Is quite different. We have the tile is much bigger. It's 128 times 128, and the scale is times 2. So the image we're gonna fit to this model is going to be 2 times larger, and the image we're going to fit to this model is going to be 4 times larger. And last but not least, the thermal super resolution is not meant to work on satellite imagery. It's meant to work on drone imagery, and it's got a tile that's 54 times 54, and it's got a scale of 2. If we give it an image, the output is going to be 2 times the image we fit the system. Okay. Only one thing before continuing. As you can see, we can select the models on our tab models. We can select them, and the last one we select, I don't know, let's suppose it's thermal super resolution, is going to show up in our selector model. Of course, here we can change it. I'm gonna show you first the most common super resolution needs, that is an RGB satellite imagery. And let's check our advanced settings. As you can see, the tile size is fixed. In this case is 64, but we can select the tile stride. The tile stride is imagine an imaginary box that moves around the whole picture, and the movement is selected by this tile stride. If we wanna select the maximal possible movement, is 64, but it's the same as the tile size. This is going to take less time, but it's not maybe going to be the perfect model. And we can select the minimum, that is 8 pixels in this case, that is going to give us the best possible resolution or the best possible model or output, but it's going to take a lot of time. In this case, I'm gonna select 32 just because I want to, not nothing in particular, not because I don't have nothing particular in my mind. And of course, we can select the tiles per batch. This is the parallel processing of our GPU in this case, because we have selected, or our CPU in the case we selected it. Mainly, we want this to be the maximum possible, unless we have occupied some of the VRAM in some other process or some other whatever process we have going on. We have the precision. In this case, I don't want to move from BF16. It's worked perfectly fine. And we have a RAM limiter. The RAM limiter in this case changes, is the 80% of our total system RAM. In this case, is 32 gigabytes. Of course, we have these dials here. We have the CPU usage, the RAM usage, the GPU, the VRAM, and the GPU temp. Mainly, what we are interested is in the GPU usage and the VRAM usage. In this case, the GPU temp is not going to be a problem. Okay, I told you that we can process one picture at a time, or we can do batches of pictures at a time, max to 10,000 images. In this case, I want to show you one single image. We have the RGB common model. I'm gonna select this satellite imagery that download from Sentinel. This is from a place in Mexico City, north from Mexico City, and as you can see, it's a satellite imagery 1024 times 1024. And I'm gonna select one. As you can see, the original shows here. I can zoom in, zoom out, move around. I can zoom in up to 800 zoom. It's a lot. 800 times is a lot. I'm gonna leave it to this. It doesn't really matter. And when I click reconstruct, it's going to show us a preview here of the work being done. As you can see, the GPU is gone to 99% and the VRAM is gone to 99%, even though we haven't reached the maximum tile per size. But we have a lot of tiles being work at the same time. As you can see, it's going to get better these images once the progress advances, and we cannot select any other button unless we click cancel. Okay, in this case, cancel is gonna drop the work and it's not going to give us the picture. As you can see, we have a 4 times resolution, super resolution model here on the right on reconstructed, and we can zoom in, zoom out, whatever we want. As you can see, it's a little more clearer, not perfect because it's not a finished product, this one, but it works really well on this satellite imagery. If we wanna, this picture is reconstructed, it's in RAM, but it's not saved. If you wanna save it, you can save result as. I'm gonna select test output and I'm gonna drop the image right there. As you can see, it show us the image, and if I go to test output, well, I have here the super resolution image, 9096 by the same. It's quite a large picture, and we got zoom in, zoom out, and whatever we can do on Windows. Okay, let's continue. Let's if you select a model, let's keep it with RGB, and we select an image that is not RGB. Let's see what happens. I'm gonna show you again our dataset. I'm gonna select a different dataset. This is a near infrared and shortwave infrared dataset from the same location. But as you can see, the original is loaded, but the model says, okay, you have an RGB, you are loaded an RGB, and an L grayscale image was detected. Okay, and so it won't work. We can open images and we cannot cancel. We cannot do anything. We cannot do anything. But the image is shown here. If you wanna work on that image, we have to change the model. Here we select near infrared. I'm gonna load an image. I'm gonna select an image. There is no problem, and this model is different. The tile size is 128, and that's it. That is what it changes. Of course, the maximum tiles per batch is calculated, the size of the image, the type of the model, the maximum VRAM available. So it's gonna change from model to model, from image to image. Okay, I'm gonna click reconstruct, and the image is going to, as you can see, it's a times two super resolution model. So we have the input at 1024 and the output 2048. It's doing it quite fast because I'm selecting a bigger, or the maximum allowed tile stride, but as you can see, it's working just fine. Let me show you. I'm gonna load many images. I don't know. I don't want to load a lot. I want to load, I don't know. This is what, 6 images. Okay, I'm gonna load, and automatically, when I load more than one image, I see 2 to 10,000 images, it's going me to ask to select an output folder. In this case, I'm gonna select the same output folder, and you can see I don't have a preview. I have the mosaic of all the image selected, but I don't have a reconstructed, or I don't have a preview of what is being reconstructed. Of course, we have the same detection, we have the same validation. If we have in the batch an RGB image or somewhat other image, it's not going to work. It's going to become an error. Of course, it's going to work on the images that can be reconstructed with this model. As you can see, it's going to take 35 seconds, the whole image. And we have processed, this is not completely translated to, right now, but we have processing picture 3, fails, we have 0 pictures, and is reconstructing the batch number 6 from that picture. As you can see, the GPU and the VRAM are loaded and unloaded depending of the work we are doing. And this is going to finish in 7 seconds, 5 seconds. As you can see, the temp is not a problem. We can work up to 80, 85 degrees. Okay, we have an output here. We have the output is this one, the one I selected before. We don't have any failed pictures. We have 6 total pictures in this case, and we have 6 processes. The program Argos is going to generate a CSV report and a JSON report. We're going to check it out right now. As you can see, this is the RGB image, and this is the near infrared super resolution image. Okay, we have here and CSV is not. It's a simple, very simple CSV, and we have a JSON file, which with much more information, like the total time it took to do these batches, the total images. All of the images are right here. The status, the file selected, the output location, the size of the input, the time it took to recreate that image, to process, sorry, that image. Is quite useful. Okay, and last one, we have the thermal super resolution. In this case, it's not. We can use satellite imagery, grayscale even, but it's not going to work that well. I'm gonna select a thermal UAV dataset. This is from a drone. It's not the best quality image, but as you can see, we can select the tile, the stride, and the tiles per batch. We can select everything we want. Okay, I'm gonna click reconstruct. In this case, selected the GPU, and it's going to finish in 5 to 10 seconds. As I told you before, when we select one picture, we don't have to select the output folder. We can check it out how this works, how it looks. We can zoom in, zoom out. As you can see, this is not a perfect super resolution picture, because it's a very low quality image, but it somewhat generates a little bit more of details, or rescue a little bit of that detail that is not completely clear. If you want to save, you can click save, and in this case I can select the save output, or whatever we wanna do. As you can see, this is the input size and this is the output size. This is different from any one of them. And well, let me show you how to load a complete folder. We have in images, we have all the pictures. I don't know how many out of them. I'm gonna select the test output, and as you can see, we have 2,866 images. This is going to show you a random image, 100 random images from that dataset. We can select reconstruct, and it's going to start working. It's going to take a while, but it's going to start working. But the main thing I want to show you is to work with a processor, not with the GPU. I wanted to show you how to use the CPU, which is actually the same, but it's of course going to take a lot of time. This as is testing the whole data set that we introduce. I wanted to tell you that this is well, maybe it's not a pre-alpha, it's an alpha. It's an alpha software. It installs no problem in Windows 8, 10, and 11. It works Of course, in Linux, there is no problem with that. With Ubuntu, I don't know, from 16 to 24, I think I tested it. So there is no problem there. From at this time, it doesn't work with a Mac, but I wanted to work with Mac, with Apple Silicon. In this case, I won't give any support to Intel Mac, so that is that. But in this case, as you can see, the image is being processed. We have 1 images, and the estimated time is 46 hours. This works on laptops, on desktop PCs. There is no problem with that. Of course, if you have a GPU, it's going to work much faster. Let's see. We have here 46 hours. I'm going to cancel it. I'm gonna keep the selection as it is, and I wanna select my GPU, which is not particularly fast, but it's going to be really fast for this occasion. As you can see, it jumps to 100%, and instead of 48 hours, it's going to take 2 hours. So that's the difference. It's massive. As you can see, it's now 5 images and 0 fails and 5 processes. Okay, that's it for this time. I hope this software is interesting to you. I'm not going to publish the code, but I'm willing to listen to any recommendations you guys have, to any critics you have. This is just an alpha. This is a test, and the main thing is we can add. I'm going to cancel it because otherwise I cannot go to models. The main ability of this software of Argos is to add new super resolution models. I don't know if you want to create a special super resolution model from drone imagery or any particular situation. You can add it, and I want to show you the last thing before I forgot. I want to show you that you can load big images. There is no problem loading big images. I'm gonna select a 4K image. In this case, I'm gonna use this data set that is mine from that I built with a drone that I have, and I'm gonna select reconstruct. As you can see, this is a 4K image. This is a 16K image. It's a massive image. The maximum allowed is by Argos is 21,000 times 21,000. It's a massive image. This is a maximum allowed. Of course, if the RAM is completely used, you're gonna get an error. If the VRAM if it doesn't fit in your computer, you're gonna get an error. But it can handle massive images depending on your system. But well, this is going to take a lot of time because this is a 4K image. This particular model is not perfectly fine-tuned for this super resolution, but it works. There is no problem. But to show you that it works with very big images. So thank you once again. See you next time.